Dear students, let us talk about some more polymers. So far, whatever we have discussed, they were all homopolymers because they were made up of only one type of monomeric unit. Now we'll take up some more examples of addition polymers where the monomeric units are more than one. So we call them copolymers. The first one we take up is BUNA-S. Now what does BUNA-S stand for? Out here, Bu stands for butadiene, Na stands for sodium, and S stands for styrene. So the name itself will tell you what it is. Okay, butadiene. Buta means for, you know that buta means for. Diene matlab, diene means there are two double bonds. So one of the double bonds is between carbon 1 and carbon 2. Another double bond is between carbon 2 and carbon 3. And what is styrene? In ethene, if you replace one of the hydrogens by benzene ring, then the compound which we get is called styrene, and the initiator out here is sodium. So we call it BUNA-S. So when addition polymerization takes place, what happens here? All the double bonds break homolytically. All the double bonds here. Okay. Now each of the carbons now generate a free radical. Now the free radical between carbon 2 and carbon 3, they couple together and they form a double bond, and carbon 1 gets attached to the CH2 group of styrene, and carbon 4 and the carbon attached to benzene ring, they remain with their free radicals. And these two ends, they are now ready to take up more reactions. That means they are ready to attach to some more materials. Like here at this end, it can attach to another styrene. At this end, it is capable of attaching to another butadiene. So this way, the polymeric chain which we write is, you can see, since the chain is extending from here, we write a bracket by cutting the bond. CH2, the double bond changes to single, then CH, the single bond now becomes double, CH, double bond, CH, then again the double bond becomes single bond, then this CH2 and this CH2 get linked, CH2, CH2, and here we have CH with the benzene ring, and the chain will extend from this corner. This is called styrene butadiene rubber also. Okay, it is a kind of rubber and it is called SBR, and the full form of SBR is styrene butadiene rubber. The next polymer we are going to talk about is BUNA-N. BUNA-N, as you can understand, Bu stands for butadiene, Na stands for sodium, and what is N here? N here is acetonitrile. That means the same compound which we have used in preparation of PAN. If you check the previous note, we have used acrylonitrile in the preparation of PAN or Orlan or acrylic, which is a fiber, okay, used for making clothes. So here also the addition will take place exactly the same way. All the double bonds will undergo homolytic cleavage. This C will get attached to this C through free radical combination. The two free radicals will couple here to form a double bond, and this free radical and this free radical will be free to take part in chain formation. So you please note here the double bonds between C1 and C2 and C3 and C4 changes to single bond, and a double bond is formed between C2 and C3. Now you are expected to study their properties from the textbook. Both of these BUNA-N and BUNA-S, they are rubbers. Now we move to the next category of polymerization, that is called condensation polymerization. Under this, the first one is polyester. Next one, number 2, is polyamide. Please check the sequence. While making the flowchart, we had to write not in the sequence. I couldn't follow the sequence due to some reasons. Then number 3 is phenyl formaldehyde resin. And lastly, we have melamine. So today we shall take up polyester and polyamides. Now, as the name suggests, polyester, you can understand here the chain which will be formed will have too many ester groups. Ester, poly means many. There will be too many ester groups. And now what is the definition of condensation reaction? When monomers combine together with the loss of simple molecules like water, carbon dioxide, ammonia, etc., it involves a series of condensation reaction involving two monomers. Usually, the monomers react to give a distinct bifunctional product and not a reactive intermediate. This is very important. You have seen in addition polymerization, we have landed up with free radical after every step of reaction. But here, after every step of reaction, we don't encounter any particular intermediate such as cation, anion or free radical. We get a distinct bifunctional product. So at any point of time, you can stop the reaction. So because of this reason, it is called step growth polymerization, not chain growth polymerization. Okay. Now you know that how esters are formed. Esters are formed by carboxylic acid and alcohol in presence of an acid catalyst. It gives you ester and water. So here also when we prepare polyesters, we take the similar combination. But one thing special about condensation polymerization is when you take the monomers, they must have two functional groups, similar or dissimilar doesn't matter. So here for ester formation, as you know, we need acid and alcohol. So we have chosen the alcohol to be ethylene glycol. Again, I am reminding you, the polymers are named by their common names, not by the IUPAC name much. So here, the monomer out here is ethylene glycol, which is CH2CH2 having two OH groups on each carbon. That is ethylene glycol, N numbers. And we take a terephthalic acid. When you pronounce this name, the P is silent. Okay. Terephthalic acid is nothing but a benzene ring having two COOH group at the para positions. So from alcohol OH is lost and from the acid H is lost, and that's how this whole group gets lost and we get an ester linkage, COO linkage. So you can see here I have written the stepwise reaction also. After the first step of reaction here, that means from here to here if I write, you can see you are getting HO, then CH2, CH2, OCO, benzene ring, COOH. So you can notice here, after the first step of reaction, again we get two functional groups on at the two ends of the chain. Now since this end contains OH, it is capable of reacting with another acid group. And since this end contains acid group, it is capable of reacting with another alcohol. So this way the carbon chain length can keep on increasing, and you may notice here we have taken n molecules of alcohol and n molecules of acid, but the water lost out here is twice n. And this reaction demands a catalyst which is zinc acetate followed by heating. Please remember, in condensation reactions we usually don't use peroxide because the mechanism is not free radical. So you know what some of the properties of polyester you might be knowing. There was a time when polyester clothes were very much available in the market. They are highly durable, okay. They are not attacked by pests, and they have low water retention. So if you wash, they immediately get dried. They don't form wrinkle, so no ironing needed, and the colors, they remain for long, they don't get faded. There are so many qualities of polyester clothes. The next condensation polymer which we are going to study is polyamide. Now as the name amide. Now what does amide mean? Amide means when carboxylic acid react with amino group, okay, RNH2, a molecule of water is lost and a class of linkage which is formed here is CONH, that is called amide linkage. So what are the starting materials needed for polyamide formation? You need carboxylic acid and you need a amino group. Okay. So we have to do two polyamides. One is nylon 6,6, another is nylon 6. Now what does the name nylon 6,6 mean? Nylon, the name is derived because it was discovered by people, one from New York, another from London. Okay, so from New York, NY is taken, and from London, LON is taken. That's how it has been named nylon to honor both the persons. And why is it called 6,6? It is called 6,6 because both the monomers contain 6 carbon. So what are the starting materials? As you know, you need a carboxylic acid. So the carboxylic acid taken here is adipic acid. Again, it is a common name. Now, since it has to have 6 carbon, you can understand COOH and COOH will be at 2 terminals. So 2 carbons we have already taken care of. And in the middle, we should have 4 more carbons. So CH2 4 times. This is called adipic acid. You must have learnt it when you have done carboxylic acids. And the other group should be amino group. So what amino group we take? Hexamethylene diamine. Hexa, as the name suggests, 6. Methylene means CH2 group. Hexamethylene, so CH2 6 times. Okay, CH2 6 times. And diamine means there are 2 NH2 groups at 2 terminals. As I have been mentioning earlier also that for condensation polymerization, we need bifunctional monomers. So here you notice that both are having 2 functional groups and both the functional groups are same in the same molecule. So when you heat adipic acid and hexamethylene diamine at high pressure, what you get is nylon 6,6 together with the formation of a amide linkage. So here, from here you can see H is lost and from here OH is lost. So what will be the polymeric structure? The polymeric structure will be, I have written the reverse way, you can always change it. The polymeric structure will be CO, then CH2 4 times, CONH, CH2 6 times, NH, and then we draw the bracket and show N here to express the polymeric chain. Nylon has many use. Nylon threads, you must be knowing, they have very high tensile strength. That means they can withstand a lot of force. They don't tear. Nylon socks you are wearing. Then it is used in making fishing nets. So many other properties. So please go through the properties and uses of nylon. And if you check the board papers, nylon is a very commonly asked question in the board exams. The next one is nylon 6. As the name suggests, you can understand here we have only one monomer containing 6 carbon. Now what is the monomer here? The monomer is commonly known as caprolactam. Caprolactam is a cyclic compound having 7 members, and here also we have an amide linkage. You can see CONH. So NH is one of this N is forming one of the members of the ring structure. Then there are 6 carbons, 1, 2, 3, 4, 5, 6, and the 6th carbon is containing a C double bond O group. So altogether there is a CONH group already existing in an amide group. But as long as it is in the cyclic form, it cannot take part in polymerization. So first of all, we have to hydrolyze it and break the chain. So when we hydrolyze this, you can see here I have written HOH. Please ignore this. And we break the bond. So what do we get here? One end we get NH2, then CH2 5 times, and then COOH. Okay, so you may note here the total we have 6 carbons here. And here we have 2 functional groups, and coincidentally the 2 functional groups are different. If you have same functional group in the same monomer, they cannot undergo self-condensation reaction. But since here the 2 groups are different, they can get linked to one another through self-condensation reaction. So the polymer which will be formed here is NH by losing this H, and we have to take away this OH, and we get NH, CH2 5 times, CO n times. Again, I suggest that you should study the properties and uses on your own. So these two are the condensation polymers. One is a polyester, another is a polyamide. In the next class, we shall be studying phenol formaldehyde resin. Thank you.